Hello and welcome to this presentation. This presentation is for term project of the course Construction Productivity and is represented to you by Group 15. Our group members are Saurabh, Sanjit, Sadaf and me, Negin. All of us are master's students in Construction Management program at University of Illinois at Urbana-Champaign. Outline of this presentation. First, the description of the project would be given, and after that I'm going to introduce the case we chose to study for this project. Then we go to the main part of this presentation, which is crew balance charts and 3 proposals that was provided by our group for increasing the project's productivity. Then we have the calculations, followed by process chart and flow diagram of the project. And at the end, in conclusion, we will suggest which proposal is the best in our minds and why. Project description. We were asked to use the knowledge gained throughout the semester to study a construction operation and suggest productivity improvements. We were free to choose any type of construction operation if they had a crew of at least 5 members and at least one type of equipment in use. We could choose between the projects we studied for our web journal, but in this group we decided to go with a whole new project because at least 60-minute videos were not available on those projects that we studied. We used crew balance charts, process charts, and flow diagrams to analyze our existing operation conditions, and we also used crew balance charts to provide 3 different proposals for improving the productivity of the project we studied. As mentioned before, we used these 3 methods. First, crew balance charts, second, process charts, and last, flow diagrams to discuss this project's productivity. Introducing the case we studied for this project. It was a trench excavator on the street and we had to choose at least 5 members on the crew. So we decided to choose 3 laborers, 1 foreman and 1 equipment operator on the site. We observed our crew members for 60 minutes and then we developed the crew balance chart. We also produced 3 proposals in which we eliminated labor 1 in proposal 1, labor 2 in proposal 2 and labor 3 in proposal 3. We also calculated the output rate and the productivity rate for our crew members and suggested which of the proposal is the best to go with in terms of increasing the productivity of this project. Initial conditions of the case. Data was collected via watching a construction process through a webcam and observing the crew members and the staff working on the site. A foreman was observed on the site guiding all the laborers and the equipment operator on site. 3 laborers were studied in this project and detailed observations on the activities of those workers were carried out to obtain the crew balance chart of the whole construction process for a period of 60 minutes. The crew balance chart shown in the next slide consists of 3 laborers, 1 foreman and 1 equipment operator. The first crew balance chart presented is based on the initial conditions of the activities done by the crew members. First, I'm going to give a brief explanation on what is a crew balance chart. Crew balance charts are used for evaluating the effectiveness of workers, any kind of equipment used in the construction, or a worker-equipment combination to demonstrate interrelationships between the activities performed by the crew members. Crew balance charts present a simple, fast, and easy way to understand alternative options for doing tasks on site. Any practicing project manager can use these charts to improve construction productivity and job site labor performances. Okay, as you can see in this slide, we have our first crew balance chart, which is for the initial conditions of the project. We have 5 different columns. Starting from the left, we have laborer number 1, laborer number 2, laborer number 3, and foreman and equipment operator. The gray areas shown in the columns are idle times, and we tried to eliminate these idle times as much as possible in our proposals. Moving forward to our first proposal. In our first proposal, we eliminated laborer number 1 from the crew and assigned tasks done by him to other crew members available, which are 2 other laborers and the foreman. As it's obvious, we couldn't assign his tasks to equipment operator. Then we created the crew balance chart for this proposal. We were also able to compress activities by eliminating their idle times as much as the job logic would allow. This proposal ended up having a 46 minutes duration. We also calculated the output rate as well as the productivity rate for this proposal. And here is the crew balance chart for our first proposal. As you can see, laborer number 1 is eliminated and we have 2 other laborers and 1 foreman and the equipment operator. As you can see, on the first 2 times that the excavator is being operated, we have the idle times on the columns, or activities like bringing some equipment to the trench assigned to our workers. And the reason behind that is on these first 2 steps, the trench is so small that the workers cannot get inside the trench while the excavator is working on that. So in these 2 times, we need the idle times to be there on the columns and they're not going to be eliminated. Here we have the description of activities that were shifted and assigned to other crew members. For example, we have measuring depth, which was done by laborer 1 assigned to laborer 3. Or we have bringing equipment, which was done by laborer 1 assigned to the foreman, and so on and so forth. And on the next column, we have the time intervals of when the tasks were shifted. Moving forward to the second proposal. In the second proposal, as mentioned before, we eliminated laborer 2 from the crew and assigned tasks done by him to other crew members, which are laborer 1 and 3, and also the foreman. We developed the crew balance chart for this proposal, and we were also able to compress activities by eliminating existing idle times as much as the job logic would allow. And this proposal ended up having a 53 minutes duration. We also calculated the output rate as well as the productivity rate for this proposal. And here we have the crew balance chart for the second proposal. As you can see, laborer 2 is eliminated and we have laborer 1 and 3 and foreman and equipment operator. As mentioned before, for the first 2 times that the excavator is operating, we have idle times on the workers available on site, or activities such as bringing equipment to the site or any type of activities that were done outside of the trench, because in this step the trench is still small and the workers cannot be excavating the trench simultaneously while the excavator is operating. And here again we have the description of activities that were shifted or assigned to other crew members. For example, we have hammering and drilling, which was done by laborer 2 assigned to laborer 1. Or we have measuring depth, which was done by laborer 2 assigned to the foreman, and so on and so forth. And you can see the timings of these shifting or assignings. We also eliminated idle times, which led us to have a 53 minutes duration for this proposal. And here we have our third proposal, in which we eliminated laborer 3 from the crew and assigned tasks done by him to the other crew members available on site, which again are laborer 1 and 2 in this case, and the foreman. We also developed the crew balance chart for this proposal. We are also able to compress activities by eliminating existing idle times as much as the job logic would allow. This proposal ended up having a 50-minute duration, and we also calculated the output rates as well as the productivity rates for this proposal. And here is the crew balance chart for our last proposal, in which we eliminated laborer number 3. We still have laborers number 1 and 2 and foreman and equipment operator on site. And as you can see, and as it was mentioned before, for the first 2 times that the excavator is going to excavate the trench, we have idle times or activities assigned to laborers, such as bringing some equipment to the trench, which don't necessarily need the workers to be inside the trench. And here we have the description of activities that were shifted and assigned to other crew members in this proposal. For example, we assigned measuring depth, which was done by laborer 3 to laborer 2. Or for example, we assigned excavation, which was done by laborer 3 to both laborers 2 and 1. It's also worth noting that in our first or initial condition, we had the activity measuring depth done by all 3 workers and foreman, and if you pay attention to our first crew balance chart, while workers were doing measuring depth, we had the foreman helping them. So we decided to assign measuring depth to foreman, and in this case, instead of having one worker doing the measuring depth and foreman helping them, we have only the foreman who is good at this job doing the measurings. Here in this slide, I'm going to explain the formulas we used in our calculations. To calculate the output rate, we divided the excavated cubic yards to the hours, and the output measures the number of cubic yards excavated per hour. And for productivity rate, which shows how much cubic yards of excavation a man can do in an hour, we divided the estimated output per hour by man hour. Here in this slide, we have the productivity calculations for initial condition of our case. To generate the most suitable solutions, the calculation of productivity of the crew members is required. We calculated the productivity rate using the resources in our project. The resources used are as follows: 3 laborers, 1 foreman, and 1 equipment operator. So case 0, which is our initial observation from the video, our output is 6.11 cubic yards per hour, and we have 60 minutes divided by 60 minutes, which is 1 hour. And our productivity rate in this case is 1.22 cubic yards per man hour. Here in this slide, we have productivity calculations of crew members for proposal 1. So in this case, our resources were 2 laborers, 1 equipment operator, and 1 foreman. And our output rate in this case is 7.96 cubic yards per hour, and our productivity rate is 1.99 cubic yards per man hour. Here we have the productivity calculations of crew members for proposal number 2. The output rate of this proposal came out to be 6.91 cubic yards per hour, and the productivity rate for this proposal is 1.72 cubic yard per man hour. And lastly, the productivity calculations of the crew members for proposal 3. In this case, our resources were 2 laborers, 1 foreman, and 1 equipment operator. And our output rate was 7.33 cubic yards per hour, and the productivity rate of this scenario was 1.83 cubic yards per man hour. Here in this slide, we have a table showing the output rate and the relevant productivities. As you can see, we have the initial condition which had the output of 6.11 cubic yard per hour and the productivity rate of 1.22. We have the first proposal which had the output rate of 7.96 and productivity rate of 1.99. And then we have the second proposal which had the output rate of 6.91 and productivity rate of 1.72. And the last proposal which had the output rate of 7.33 and productivity rate of 1.83. Moving forward to process chart, here in this table we have the process chart information, and these are the symbols that we used for our process chart. First, we have the yellow circle, which stands for operations, which in this case is mainly excavation. And then we have the transportation symbol, the inspection symbol, the delay symbol, which stands for temporary storage. And then the purple symbol, which stands for storage or permanent storage. So here we have the process chart for the project, and it's worth noting that the process chart is made for initial conditions of the project, not the three proposals that we provided for increasing the productivity. Here we have two tables. On table number 1, we have workers excavating the trench, measuring the trench's depth, the excavator transporting soil from the trench to the truck, and these items all have the operation symbol. And then we have workers bringing more equipment to the trench with transporting symbol, and then we have supervisor checking the depth of the trench with inspection symbol, and so on and so forth. Okay, next we have the flow diagram of this project. It was a trench excavation, and the excavation was being done by both the excavator and workers. We also have a truck there to carry the soil which is excavated from the trench. And we also have an inspector who measures the depth and width of the trench while the workers and the excavator are working on it. We also have two different places on the project to store the both excavator while it's not needed and the truck while the workers are busy fixing the cables in the trench. So here are some more explanations of flow diagram. In the flow diagram, a series of activities can be seen which are being carried out around the trench. Excavating activity is being carried out by both the workers and the excavator, as it was mentioned, and an inspector can be also seen inspecting the trench depth and width, and as it was mentioned, in this case it is the supervisor. And then a dump truck can be seen waiting on the other side of the trench to get loaded with the excavated soil, and workers can be seen bringing some equipment from the temporary storage near the trench, and also the excavator is moved to the temporary storage when it is not required. So here in this slide we have the output rate graph, and as you can see we have the initial condition which the output rate was 6.31. Then we have our first scenario or our first proposal which had an output rate of 7.96. Then our second proposal which had an output rate of 6.91, and then our last proposal which had an output rate of 7.33. And here in this slide we have the productivity rate graph, and our initial condition had a productivity rate of 1.22. Our first proposal had a productivity rate of 1.99, and our second proposal had a productivity rate of 1.72, and our last proposal had a productivity rate of 1.83. And as it can be seen in both this slide and the previous slide, the best scenario is the first scenario or our first proposal, in which we eliminated the labor number 1 and assigned his tasks to the other two laborers and foreman. And lastly, here we have the conclusion of this presentation. In conclusion, we selected the first proposal. As in the first proposal, the laborer 1 was eliminated and the idle times were adjusted and the cycle was brought down to 46 minutes. It has an output rate of 7.96 cubic yard per hour and a productivity rate of 1.99 cubic yard per man-hour. We selected this proposal as removing the first laborer resulted in a higher amount of productivity and the output rate compared to the other proposals where laborer 2 and 3 were eliminated. So this presentation comes to an end at this point. Thanks for your attention, and if you have any questions regarding the presentation, feel free to email us.